There's a couple things I want to talk about in the process of learning how to build this that took me several months. A lot of that was just going into town and talking to people who actually work on hydraulics, and my limited knowledge of hydraulics and hydraulic installation over the years was not quite enough for me to figure out how all this is supposed to work. The internet is a useful source, but for some reason, whenever I watch a video about how to build something like this, they skip out on a lot of that information. So I just wanted to talk about some of the stuff that I learned along the way that I didn't find on the internet. I either had to find it on my own, or I talked to some professionals and they were the ones that were able to set me straight. The first thing I want to talk about is how to identify what kind of parts that you want. I had to go to, again, a professional who has his own shop and everything, and ask him. I brought him the cylinder that I got from a scrapyard for $50, and I asked him not only to check it out to see if it was actually good and if it was going to hold up, but also to kind of pick his brain and ask him about what I needed exactly. When it comes to cylinders, the way that you gauge how much power it's going to output is based on the diameter of the inside of the can, so the inside of the cylinder where the hydraulic oil goes, the diameter of the inside of the can minus the diameter of the rod. So the actual area that goes into the cylinder in between the can and the rod will give you the numbers you need to crunch to figure out how much actually output you're going to get. And that's a whole calculation that he did out for me, and I'm not going to pretend like I understand that. But that's what you have to look into. This rod is actually kind of thick compared to most cylinders that you get. It's closer to 2 inches, and then the can is about closer to like 4 inches on the inside. But you don't calculate the volume, you're just calculating the area, and that will tell you how much power output you can get from it. Right? If you were to calculate the length with that to get the volume of the inside, that's not going to tell you nearly as much about how much power there is. The length of the cylinder only tells you how long the cylinder can reach out. So you have a nice long cylinder with a long ram in it, it can reach out really, really far, and that's great for certain operations. But if you're just doing a press like this, 10 inches of stroke, 9 inches of stroke, 8 inches of stroke could be plenty for what you're trying to do. So you don't necessarily need a long ram, but you do want a thicker ram, a bigger ram. Greater diameter has a lot more to do with power than anything else. Once you've identified what kind of ram that you have, what kind of ram you want to run, then you have to figure out what kind of motor and pump will actually run that ram. When I asked the professional, he told me that what I needed was pretty much exactly like a hydraulic log splitter setup, which is you want at least like 11 gallons per minute. Mine's 13 gallons per minute. That's a pretty common one. And what you'll find when I'm pointing out these different parts of it, everything's a little bit overrated for what you need. And that's a big important part of building hydraulic components. You want everything to be overrated from what you're actually going to be outputting. So if you know you're going to be putting out a maximum of 3,000 PSI because of the type of pump that you have, and that's the max that it can put out, then you want to make sure that your hoses and your spool valve are all set for more than that. So these hoses are all max capacity is 3,600 PSI. Gallons per minute though will tell you how fast a ram will go. Because if you have way less than that, only 8 gallons per minute, not only will it not go very fast, it'll go quite slow, but you'll also be lacking potential. You'll have so much potential in this ram, but it's just not going to be able to put out that much power. So it has to match that. So between 11 and 13 gallons per minute, I would suggest going 13 gallons per minute because it's just as common as 11 gallons per minute. So just go ahead and do that. As far as the valve goes, again, this is rated for more than 3,000 PSI. It's got an adjustment screw on it, so you can adjust how much PSI you actually want to put out. I talked to the great Glenn Gilmore. He lives down in the Bitterroot, and he makes these amazing presses. They're really, really good, and I learned a lot from him just going down there and talking to him. One of the things that he taught me about spool valves is that that's actually where a lot of people go wrong, is with their spool valve. Is they'll get everything together, they'll have all the right stuff, and they'll get their press together, and they'll go to press something, and it just won't quite do it. And he said a big fault on that is that there's an adjustment screw on that. Some of them are really obvious. Mine's got a big bolt on the side of it that's obviously the adjustment screw, and then others have smaller adjustment screws. but you have to look at your adjustment screw on your spool valve. Other valves that are not spool valves won't even have an adjustment valve on it. There's a lot of hydraulic valves out there, and I actually had a scrap one that I tried to use on this originally, and it just didn't work. It just wasn't the right thing. So you need a spool valve. Prince makes great spool valves, but there's other companies out there who make pretty much the same thing. But if you're running that spool valve and you're just not getting the power that you're looking for, you might want to look at adjusting that, because you probably have a lot of potential from your cylinder, potential from your pump, but it's just not quite getting through the spool valve. So you need to adjust that, make sure that you're not running at like 2,500 PSI when you should be running at like 2,800 PSI. There are electric motors and there are gas motors. Electric motors have a horsepower rating. Gas motors have a horsepower rating. They are not the same. If you're going to be running a 2 horsepower electric motor, you want to have way more horsepower than that if you're going to run a gas motor. A 212cc gas motor from Harbor Freight has about 7.5 horsepower. So that's way higher number than an electric motor would be. So you're well over 3.5 times as much. Honestly, now that I built this and I'm using it and everything, I think there's so much more potential that this press could have. I think one day what I want to do is mount an even more powerful motor on the back there, just like the next step up or something, to see if I can just get a little bit more potential out of it. I tend to bog down a little bit too much, and I feel like the problem with that is the motor. So real quick, I wanted to go over the main thing that took me the longest to try to figure out, and eventually I just kind of had to figure out on the spot how this actually works. Another thing that when people build presses, they make YouTube videos about it, for some reason they just don't go into a whole lot of detail about this. And maybe it's because there's a couple different ways you can do it depending on what your setup's going to be like. But again, it's just like they had to make it the most complicated way possible. I'm just going to explain it as simply as I possibly can. This is how the hydraulic get to the cylinder and back to the tank again. On the back of this machine, I have the hydraulic reservoir. Got a cap on the top there to add more as you go along if you have any leaks. On the back side of this, you have a fitting that's on the top and a fitting that's on the bottom. Whichever one's on the bottom is going to take hydraulic oil from the bottom. So it doesn't matter what level you're at, it's always going to draw from the bottom. That's going to go up. It follows this hose, goes right into the side of the pump. The pump has an arrow on it, not all of them do. This tells you what direction, when you spin it, it's going to go. Something to keep in mind, not all pumps are designed for the same direction of spin, so you have to make sure you have the right one. Again, if you're just buying a common pump that's designed for a log splitter and a common motor that's designed for a log splitter, they're probably going to be the same direction and it's going to work out just fine. But the pump sucks oil in from the bottom of the tank up through this hose, through the pump, out the other side, and this hose goes directly into the inlet of the spool valve. If the spool valve is not in use and it's in the neutral position, so there's down and there's up, but then there's neutral. If it's in the neutral position, that hydraulic oil goes straight through the spool valve and out the other side. It doesn't go to the cylinder at all. And it goes back to the return line. It goes straight down this hose and it returns back to the hydraulic tank via the filter. This is typically where you want the filter to be. When I first built this, I put the filter on the intake from the tank. That's not good because it's actually sucking that hydraulic oil through the filter and you're not going to get as much gallons per minute. So that's how the oil returns back to the tank. And again, nobody told me how to do that. It immediately redirects and goes back to the tank, and it's constantly cycling as long as the machine is on. If you then lift or lower the lever to engage the cylinder, it then redirects the oil to one of these two hoses. So these two hoses switch back and forth between which one is putting oil in and which one is taking oil out. So if you want it to go down, then you want this top hose here to go to the top of the cylinder, which if you build it a different direction, it'll be the bottom of the cylinder. But the bottom of the cylinder, the oil goes into the cylinder and pushes the ram down, while oil from the top of the cylinder comes out and goes back to the valve, getting redirected back to the reservoir. If you want it to go back up, then oil will come to the top of the cylinder, pushing the ram back up, and then the oil on the top will go back out to the valve and get redirected to the reservoir. This design of press with the outside and inside frame, I would say is actually fairly easy to make compared to what other people are making. You got to really machine that stuff pretty close, otherwise you're going to get like a lot of slop in the carriage, especially if you're doing a C-frame press rather than an H-frame press. H-frame presses are just easier to build to begin with, so if you want to do that, they're easier to build. You can build them out of significantly lighter stock material because it's supported on both sides evenly rather than just one side. If you're going to build a C-frame press, you really got to go all out on it because people build them out of I-beams all the time. I-beams really aren't designed to do that. They're designed to flex under pressure, but that is not what you want. There's a reason that Cole Iron Works makes their presses, their C-frame presses, just out of a huge chunk of like inch thick, 1.25 inch thick plate, and it's like that wide. Because that's how much pressure you're going to be taking on a C-frame and how much it's going to bend it. So H-frame presses are just easier to build. This particular design, as far as H-frame presses go, is actually fairly easy to make. As long as you can make a square frame, you got this under control. There's not a whole lot of machining going on. It's mostly just welding and drilling a few holes. Building this thing took a long time, not only because I spent a lot of time researching and trying to figure out how to actually do it, but one of the things that I really wasted my time and money on building this was spending too much time with just junk components. It's one thing to build the frame and everything out of junk. It's one thing to go to a scrapyard and find a cylinder that's in good shape and buy that for pretty much nothing. It's a whole nother thing to cheap out on the pump and the valve, because when somebody gave me the reservoir, the oil reservoir here, they also had other components on it. There was a valve and there was a pump on it as well that came with it. So those are junky, old, they came from an old dump truck. And I thought, you know, it'd be pretty cool if these things still worked and I could just use it for this press. There are a lot of hydraulic components out there, and you can waste a lot of time and a lot of money trying to get those things to work for something when it's just not the right thing for it. So my suggestion to you, if you want to build one of these, don't cheap out on the pump, the motor, or the valve. If you're going to build a press, I want you to really consider how much of a press you actually want. Because I've spent all this time and money and effort on building this, and I got to a point where I'm like, look, I'm glad I have this, because this thing can do a lot more than what I was able to do before, and it's in a lot of ways so much safer than that death trap over there. If you can go big, I would suggest you go big. If you can buy a press, honestly, I would suggest that you do that. Building a press is fun, but it's going to take a lot of time and resources and energy, and it's going to really drive you insane. Or you can buy a press from somebody that's warranted, and that's just a greater experience. The main reason that I built one for myself is because, again, I don't have electricity, so why not build it myself and make it gas powered, because nobody else is doing that, and there's probably a lot of reasons for why nobody else is doing that. I'm a little crazy. Everything that you can do with a big one, you can't quite do with a small one, but everything you can do with a small one, you can do with a big one. So why not go big? Obviously, it's going to cost more. It's going to be a little harder to source parts and resources for that. But once you have it, I think you're going to be so much happier just knowing that you can do everything that you need to do with it. So why not go all the way? If you have any questions about this press and you want to learn more about it, or you have questions about how the hydraulic components work, I would love to answer those questions if I can. And if you decide to want to build one of these for yourself, go ahead, copy this design if you want to. I would love to see any kind of pictures or videos that you have of that. Send them to me so I can see what you guys are working on. That'd be really fun.